Right, let's try this. It's not twitching anymore. It's fine. Okay, good. That's good. So let's continue with this, and I need to go back to the debug settings and look at the system and dead zone. I can turn that off now. I wonder what happens if I do it in the game though. That's a good point. If I do it in the game, how does... I should check it in the game. App A tuned? How do you mean? Hey, if you want travel guitar, I'll show you something. It's awesome. But first, I have to go into practice mode with the dead zone. I really don't want to change the dead zone settings. Shit, that's a problem. So they, on a Vita, damn, if I have to increase the dead zone. That's a bit worrying. They might flag us for that. Shit. I have a detailed I have a dynamic dead zone, but it's insufficient. What's in input? It basically means that if you've got a Vita that has a bad stick, it could, if you let go, you could actually end up with it drifting. Dead zone is the bane of video games. when you have a stick, the stick is, you let go of the stick. When you let go of the stick, you want it to, generally you don't want the thing to drift by itself. So what they do is they put a dead zone in. Everybody puts a dead zone in, and it's like, it drives me nuts, because the problem with a dead zone is it's dead, which means there's no feedback available to you while you're in the dead zone. And then you start pushing the stick, and at a certain point it starts moving, and there are different ways of implementing dead zones. And to give you an idea of how unsophisticated people's thinking can be, and I just throw this up, not because I'm trying to sort of put down people, but because it was also the same for me, and I had to figure out in the end that, you know, these things. And it's like, well, but what irks me a little bit is that everybody, when they're making a video game, they're always rushing, and so, or usually are rushing, and if they're rushing, they don't fully think things through. And so here's an example. It's like you've got a dead zone, and what the dead zone means is that you won't actually register the position of the stick until you go beyond a certain amount, edge of something. I'll show you. If I actually do, I'll call this, actually, you know what, let's call this x1, y1. Sometimes it's easier to show things. x2, y2. And I know when I was a teacher, I used to try and say, hey guys, you need to think about this. And very often people don't want to, because they're always trying to rush to the finish line instead of really paying attention. So dead zone, and why it's a problem. So what I will do is, this is the raw input of my stick, which could go between -1 and +1 in x and in z, right? And then the first thing is that there is clamping, that it won't go below -1 or +1. So I think I'll just show the clamping first of all. So x2 is equal or one way, minimum of 1, maximum of -1, x1. I think this will now be clamped to -1 or +1, and then I can do the same thing in the y. There are so many little subtleties about control, and I do wonder, you know, are these thought about really? So now what I've got is I have, okay, a dot. It's boom. Now you can see it's clamped. And just to make this a little bit clearer, I can do x2 squared plus y2 squared equal 1. Okay, why is that not working? Oh yes, because I need to do x minus x2 squared the problem is everyone's always rushing. 40, 60, 100. There we go. So you can see now where you push the stick, and the stick may physically go further, right? So that's the first thing. The stick doesn't necessarily stop here. It can go further, and that's bad, but not as bad as, it's a kind of a reverse dead zone. The reason why that's bad is that when you're in this zone, you get no feedback, so you don't know when it starts to kick in. And so you end up like on a knife edge, and it's not such a problem on the extremes because you're moving quickly. But when you get into the center, it's a real problem because, look, the stick, you let go of the stick and it won't be centered. It'll be like this because of the inaccuracy of the physical, the mechanics of the actual stick. They never end up back in the middle, which means that if I do a game which reads the stick and say moves a character or something, I let go of the stick and it's going to drift, which is actually what you're seeing on the Vita right now. It's going to drift. So I can probably just do a T and T here, and then we can have a line to it. So what you do is you want it to not move when you let go of the stick. Okay, so what we'll do is some more clamping. And say the minimum, this one's a little trickier. How am I going to do that? Okay, I'll do x3 equal if x3 is less than, if the magnitude of x3 is less than 0.2, let's say, so that will be a fifth. You can't recalibrate because it's noisy. I mean, there is already recalibration in the hardware. The point is when you let go, the precision of the stick is such that it doesn't come right back into the center. If you buy really expensive joysticks, they have a very small dead zone. The better the quality of the physical build, the smaller you can make your dead zone. But a lot of sticks that you buy, controllers that you buy, and especially if you buy cheap ones that are not PlayStation originals, I wouldn't recommend that because you don't know what you're getting. You could get some piece of crap where where when you let go of the stick it sort of sticks out like this. It's all to do with the quality of the build. And it's a real problem because as a game designer, you've got no control over that. So, x2. So I've just created a dead zone here, I hope. Is it working? No. It will be now, I think. No. Are we working now? Yeah, so now you can see it goes down to 0. I'm going to just set this up for the X and the Y. No, it doesn't mean it has actually the feel of the Vita stick is very, very good. I like it. But it means that the dead zone is bigger on the Vita than it is on the PS4. And this is because it's physically smaller, so you can't. The smaller the stick is, the more precise the engineering has to be, and so it's actually to do with that. Believe it or not, the design of the sticks on the Vita will have been a really huge problem, because first of all they need to be small, then they need to feel good tactilely, tactilely. I mean, it needs to feel good, but they also need to be strong, so they can support to the force of your thumb pushing down on them. And then you need them to be accurate. It's actually quite difficult, and you want to do all of that really well. You need really precise engineering, and that increases the cost. So what I've got now is with dead zone. So let's show what happens with the dead zoning. So now, yay, I have. Now, hopefully you'll get the point about how bad this is as an issue. And see, that's interesting that we get that shouldn't. That black dot is the wrong dot. That's why I need to change that to 3, this to 3. Hey, Stilton. But my point I'm making about this is that I know for a fact that this kind of subtlety is not usually thought about. I've watched developers, I mean, okay, student developers, but I looked at the way games, and you look at games, this is how it's done normally, and it's I hope you make the point. This is horrible. And this would be, you could say, level 1 in sophistication of dealing with your stick. Honestly, I could do a whole lecture just on this. Can you see the problem? It's like, okay, so I'm moving my stick about, and then suddenly it's like, and how many games have you played where you've seen this? But it does mean that when you let go of the stick, if it's anywhere, so I let go of the stick and it comes back to here, and it's not going to drift because I'm less than a certain amount, and so there we are. Zombies, the dead zone. Yeah. Look at that. It's horrible. And it means that when you're in this area, you push the stick and you've got no feedback, and then you have to sort of feel when there's no tactile response to tell you when you go between here and here. This is the worst possible way to do it. So, okay. What you can do is an improvement, which is that you make it so that when you go past the dead zone, you start at 0. And I'll just point something out. You've got all this movement of the stick. If you lose 20% of the thing here, you've actually squashing the available area down. You're only left with this range of movement that actually is meaningful, which is the other problem with the dead zone. So in KOR, I use dynamic dead zone, which means that you even get response in here by using some trickery. But when you let go, it doesn't start drifting off. It acts like a dead zone. The dead zone basically moves around. You could think of it as like an auto recalibrating on the fly of the dead zone. So this is the worst one that you can have. And so maybe better would be, I don't know, let's see. So if x3, we would say if the magnitude is there a good way of doing that? I have to deal with the sign. Yeah, it's the same issue. So what you can do if it's less than 0.2, then I can say that it's x2 the magnitude, so it's the absolute value of x2 minus the dead zone, which I'm going to call z, equal 0.2, so I can actually change the dead zone now. Z, I can subtract z away from that, but then I need to scale it up by 1 over 1 minus z, and then that should that's good. You got that right, lovely. But then I need to make it work for the sine, so I need to multiply it by the sine of the original x2. So this is an alternative. It looks a lot more complicated, right? But it's actually quite simple mathematics, and it's just rescaling the thing so that you see, right? It works. Look at that. So this is this is a lot better. So you're still in your dead zone, but when you exceed the dead zone, it starts from 0 there, and then we still get to the full amount by the end. So that little change, so if you've got, this is why you need experienced people working on your input. Seriously. Oh, I've done it this way as well, I think. So there we go. So now you've got a full sort of range, but you'll notice that you still have this problem that you don't know where that kicks in. So when people are playing this, they'll overshoot. They say, okay, I'm steering this way, and I push to the left, and it's like there's nothing there, and it's until eventually it starts. But you sort of push over, and then you say, oh, and then you pull back, and then you sort of, yeah, that's what I want, about here. Horrible. Horrible, horrible, horrible. But this is a lot better than what we had before. I hate that bit in the middle though, it's dead. That's why I created this dynamic dead zone. I want it to always move. I want some response there. I want you to get the feedback so you've got some idea of where you are inside this dead zone. But I mean, you know, this topic I could go on about it all day. Because look, the other thing then is this one. Oh look, I've clamped the x and the z axes to x and y axes to between 1 and -1. And then what you forget is that, well, this is a speed of 1. This is faster. This is a speed of 1.414, or the square root of 2. Because this blue line is longer now than it was here, right? So you get if you're, it depends on what kind of game you are making. If you're making a flight sim, you probably don't care, because it's okay to add 2 axes together to get some faster range of movement. But if you're making a game like KOR, you actually don't want to do that. So what you would do is you end up clamping the magnitude of the vector, because it's not, the player isn't going to run faster if I run diagonally, if I push diagonally or whatever, right? It's not going to run faster. So you end up having to clamp this vector. So I'll do that. It'll be x4 equals the x3 divided by the square root of x3 squared plus y3 squared. And then, so vector 4 is going to be the normalized x again. Okay, so we clamp that, and then what we end up right. So what we've now got is x4, y4. This blue point is the clamped. See, this is the clamped vector. This is what would happen, isn't it? Because I get the vector and I clamp it, and what you've got is this blue. So let's just move this to here. And that's it. So this again, this is naive, and I see this all the time. So we've got, right, why is it naive? Well, now we've actually got a dead zone on the end as well, effectively. Here's the dead zone in the middle, which we dealt with, but now as we pull over, you can see that, okay, we can't go any faster than 1, so it does that normalization, and now look what you've got. I think, you know, I'm moving over here. Hello, I'm moving over here, and you know, maybe it's not so much of an issue if you really can't go outside of this range, but often the sticks do not reach a limit of 1 right at the full extent, so you can actually push further, and now what you've got is a dead zone in the corner. Right? And for me, as a teacher, this was the kind of stuff I thought was important. I mean, you know, it's yeah, it's like I didn't actually. But having said that, and none of this is that obvious, and I know it's not obvious because I used to teach about input, but I would teach something else about it. But I never really covered this, because actually really properly thinking about all of this was only something I started to do a few years ago. So after so many years, it's not that obvious, but it kind of irks me that we need more talk about this kind of stuff, I think. Well, maybe there is, maybe I just don't look for it. But anyway, however that might be, look, dead zone. So this is not the right way, in my view, to figure this stuff out. Especially when you then try to do like the reverse. Well, that's another topic that I'm not going to go into right now, but that's to pick up the reversing of a stick. And I do have a reversal in a sense, because of, you can reverse the stick to raise the ball up. But just watch this. This is another thing. I'm pulling the stick back as the thing gets slow, and this stuff's mad. I'm pushing the stick this way. Right? But it's reading it as being vertical. Why? Because of the dead zone. This is right. You see how it's clamped it. So what the problem here is that people will tend to clamp the x and y coordinates and treat them as separate. And when you do that, you get this kind of nightmare. I have a dead zone over here. I've got the dead zone in here. I've got this dead zone here, a dead zone here, a dead zone here, a dead zone here. And then, if that wasn't enough, I've got accuracy issues here. I'm at 45 degrees, but it's registering as being vertical. I'd never get thin. You don't get to GDC with stuff like this. You put this stuff in, and people will say, "Oh, that's obvious." Seriously, that's what you do. It's like, that's obvious, because it's obvious once you point it out. It's like, "Oh, what's in this? It's obvious." The GDC talk. My GDC talk days are over, I think. Seriously. I think this is important, but because I think this is important doesn't mean other people think it's important too. And they have to get over themselves some of the time. Seriously. Because I'm treading in very dangerous waters here. I'm telling people how to do input. I mean, you can look at it that way. I'm telling people how to do input. And there will be people out there with 15 years experience who think they'll know everything about input. There will be those who do, but there are also those who do not. The ones that do don't need to hear me talk about it. The ones who do not have to, first of all, put aside the fact that for 15 years they didn't know about it. And it's the same with me. That's the biggest barrier I find to advancing yourself, is to acknowledge at every step that you want to advance yourself that you sucked before. I mean, metaphorically. You have to. That's the biggest. That may actually be the biggest barrier to self-improvement and learning. To do things better, you have to acknowledge that you didn't do things perfectly in the past. I don't know. It's a theory. Anyway, look. So here we are. Here's a secret. I'll give you a secret of how to deal with this. Is that you stop dealing with the x and y axes independently, and you don't clamp them independently. You clamp all together. So a very simple thing. If we're looking at, simple thing. Let's say that simple. But if I want to get rid of this problem, right? Where do I want this to be? I want it to respect the angle. It's not respecting the angle. So the way to get it to respect the angle, let's see. Well, the first thing I can do is I can turn this, I can clamp the vector instead of clamping. That's basically it. I clamp the vector instead of clamping the axes. So did you understand what I'm saying? And so the question there you have to ask yourself is, when you use some piece of middleware, like for example Unity, how does it clamp the axis? How much do you want to bet it clamps the axis independently instead of clamping the vector? It's almost guaranteed, because it's easier to implement. You just treat the two axes as independent. And in fact, the way that Unity implements its dead zone has to be that way, because it's an architectural restriction. Each of the axes are independent. You don't have an entity which is a direction from your... Sorry, you know what I'm saying? So you build the direction from two independent axes, but then you use a dead zone, and the dead zone is doing exactly this, and you can't undo it once you've done it. So what I have to do is I get rid of the dead zone in Unity. I don't use the dead zone at all. I set the dead zone to 0, and then I do my own clamping, right? I wish we lived in a world where... Yeah, never mind, I won't talk about it. So anyway, look, so if I could, what I could do is I'm going to create x5, which I already have a clamped version actually, but it was of x3, which was the one that was already... So what I've actually done is clamp the axes first, right? And then I normalized... Actually, I clamped the axes first, and then I clamped the vector. That's really what's going on here. You don't want to do that, you just want to clamp the vector. I'll just see if I can set that up. So x5, I can copy this. I mean, I know people are going... it's obvious, but I know it's not obvious. Dear me, what a mess we live in. That's 5, 5, 5, 5, 5, 5, 5, 5, and 3. So this 5 is going to be 3, but 3 was already clamped. What I really want is 2, vector 2, which is also already clamped. I need to actually go straight to 1. Vector 1 is the raw input. So I'm going to do it properly now, what I consider properly, which is to take the raw input and turn it into a vector, and then start treating it like a vector, not as independent axes. So this gives me, let me see, I'll move this to say 5. So let me just get this straight. We have wife. Oh, I'm not showing 4. I need 5. 5, 5. I'm using the wrong one. And the funny thing is, it's actually simpler in the end as well. So, right, now, all I've done... Where's this blue? That's the blue line. Oh, and the black dot. Let's put this on 5. There. All I've done is, it's actually only 2. All I've done is I took the raw input... I've taken the raw input, made it a vector, and clamped it. Well, it's not clamped right now, it's actually just normalized. So I need to actually, to clamp it, I need to multiply it by the length of the vector. Clamped to 1. So in fact we need to multiply it by the length of the vector. Did I create something to represent the length of the vector? Well, it's this, isn't it? So if this is less than 1, less than or equal to 1, then we need to respond with the length. Otherwise, we need to respond with what? With 1. Okay, so I can do that with a max or minimum of 1 and the actual length of the vector. I think. Let's see if this works. Yes. So now what you have is, as you push the thing around, as the irony is, this is actually simpler code. I've got no problem anymore. There are no dead zones anywhere because I'm treating it as a vector. And even when I go outside of this range, there are no dead zone here. No dead zone anywhere. Okay, but you can say, but there's no dead zone. I mean, so it's just, all right. So what you do is you set it to 0, not if the axes are 0, but if the length of the vector is less than a certain amount. So I can actually do that with a max, can I? Yes. I need to set if it's less than a certain amount, I need to make it 0. I'm just thinking, how can I do that? If okay, well, probably the easiest way is check for the length, and if that is less than my threshold, my dead zone, then it's 0, otherwise it's 1. I think that will do it, and it does. So now what you've got is this is all working really nicely. I don't have any problem. You see how beautiful that is. There's no there's none of this sort of jumping around or turning. I've got full precision. I have full precision here. I do not have a dead zone over here. I have no dead zones anywhere. The only dead zone I've got is in the center where you want it. Boom. And then of course you say, alright, but I actually don't want the dead zone to be, I don't want it to sort of pop to that speed immediately. It's like, you know, it's just, no. Alright, so what you want to do then is do a similar thing to what I did up there. And we need to take, we need to multiply it by this expression, I think. So let's see, 0 to 1. If the, sorry, it's beginning to get difficult to do this in my head, but what I want to do is if it is less than 0, yes, it's here. I need to effectively do the same thing with this, but instead of x2 I need to put in the length, and the sign no longer matters. So I think, I hope, I can just put this expression instead of this 1. We'll see if I'm, yes, it worked. The clamping to 1 is not working, but the dead zone, it's working. So let me just see what went wrong there, because here we got if there is less than Z, otherwise the length do I actually need to put the length in there again, or can I just put 1? No. So who is this inside? I said yes, I need that. But the problem is that now it can get I'm just sort of hacking it in. It could probably be simplified, but this is that clamping on the outside that's not working. The center is working fine now. If I'm in the dead zone, but then it starts from 0, and then, but unfortunately it reaches that point, but I just need to clamp the final value. So frankly, it's going to be easier for me just to do that as another vector here, because I'm beginning to get a bit unwieldy. So this will be a minimum of 1 and x5, and then y6 is equal to the minimum of 1 and y5, and then I can change these to 6, 6, 6, 6, 6, 6. And so the actual message here, there it is. Oh, look at that. I fell into the trap again. I've clamped it according to I clamped the axes independently. You see how easy it is to fall into that? I want to clamp the axes independently. I think a better way then of dealing with this, I need to break this down because I'm 5, 5, 5, 5, 5, and 5. Right, let's put this back. I need to clamp the vector as a whole. So probably, right, so this expression here is saying, all right, we go and I clamped it here. That clamp doesn't work anymore, so we can just get rid of that. Yeah, it was, yes. So what I want to do is clamp the distance. So what I've got is I normalize the vector, I multiply it by the distance, and I say if it's less than z, then we do all of that. What about if it's greater than 1, then we need to limit it to 1. So maybe the right approach here is to just put the length, magnitude 5. I will call this magnitude 5, and it will be easier to work this out. M5 is the magnitude of vector 5, and actually here then I can just say M5. It'll sort of simplify things a bit. That should still be working. So yeah, that's working, but the clamping to 1 is not working. So right, so M minus Z, but I want to make sure that we set a limit. I'm just thinking, how can I do that in this thing? Use Z, M, if M goes between Z, right, if M is greater than, right, I can clamp it here. I think I can clamp it here. Say we're in the minimum of 1 and this. Oh, that did not work. Let's see why. The length of the vector because multiplied by I have to use the unclamp vector here actually. I got it. Alright, so what I've got now is, what I'm doing is I'm basically working on the vector instead. I've clamped the vector so that it can't be longer than 1, but I've also made it so that it scales, interpolates between 1 and the edge of the dead zone. And this is the best solution so far. We've got nice precision here, nice precision here, everything on there, no dead zones on the edge. Works really well. But in the middle now we still have the dead zone. So what you do then is you add your that one you can't get rid of, right? With such a simple approach. So what I do then is I've got my dynamic dead zone technology is recalibrating in effect, so that you actually get rid. You don't have a dead zone at all. So that's the whole that's the whole thing. So what we went from was the very naive to the correct solution, and the correct solution is that you process the stick as a vector instead of two independent axes. Can you see the huge difference that makes? This is the good solution, and I think if we go back to I'll put the circle on the which one was it? 3. That's oh, it's the blue line. So yeah, so the blue line is showing you the old approach, and the circle is showing you the new approach. And you can see with the old approach, dead zone, dead zone, dead zone, dead zone. How many dead zones? 1, 2, 3. Oh, it's dead on one axis. So, but yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 dead zones. 9 points in the use of your stick where there is no response to a change in position. 1, 2, 3. If you're not seeing it, what I'm doing, I can move these others. Let's put them all there so it's more clear. 3, 3, 3, 3. This is really clear. Look. Dead zone. 1, 2, 3, 4, 5, 6, 7, 8, and the center one. 9 dead zones. Naive approach. 9 dead zones. Enjoy. We can, on the other hand, we can just use in the end some code which is simpler. Treat the input as a vector and actually do damn vector linear algebra on it. Very simple linear algebra on it. Treat it like a vector, and now one dead zone. About 1 billion times better. I'm going to save that graph. Dead zones. So I hope you enjoyed that little tutorial on dead zones. I hope you found it useful. Because I don't know about you, but I'll take 1 dead zone over 9 any day. And that's an example of just, how things can get missed. Anyway, back to this thing. I have a problem then, which is that I need to increase my dead zone because I'm concerned that we will get this thrown back in our faces, metaphorically, from Sony, because they'll try the game out with the dead zone test and they'll say, you let go of the stick and the player's moving by himself. Then what's really annoying is that there's a threshold that's set that is just to cater for all Vitas. It may well be that the precision could be that in practice the Vitas have a better spec than that, and so then we're reducing the responsiveness of the controls for So maybe I could put an option in there so that you can set the dead zone according to your taste. We might end up doing that, but right now I need to look at input. And there's more on that topic, by the way, because then there's the other issue, which is oh, bloody hell! There's a lot to. The other issue is then sensitivity. How do you implement sensitivity on joystick input? You want it to be move more slowly in the middle because you want more precision. But that means that when you push the stick all the way to an extreme, then the maximum speed is slower. So then, of course, what you could do is you put in a kind of a threshold. If it's less than 50%, use 1 sensitivity and then make up for it on the other one, above half. You can change it. So this way you have precision in the middle but speed at the end. Except the problem is that that kink that you have is it's like a sort of dead zone in a way. It's not really a dead zone so much as the player, when he's playing, doesn't know where that is. So you push it and push it and push it, and at a certain point it will change its sensitivity, and so he's going to be doing this kind of thing. So it's actually better to have a smooth curve, and that's what I use. One of the uses I have for my normalized tunable sigmoid functions. There's a curve that you can adjust so that you can have full range, but in the middle you can have improved sensitivity. And that is another step, and that's what I do. I use that. I want you to be able to have precision in the middle but full range of motion. So after all of that, with the dead zone processing, I then add a tunable, normalized tunable sigmoid function on the top of that. It's probably one of my most useful tools. And I did do a talk at GDC on this, believe it or not. But I was disappointed with the response, frankly. But maybe I didn't explain it very well, or maybe people have trouble understanding when they, need to look at the way that works. This is a lovely demo of that. I have here the range of motion for one axis is moving left and right, and it's a linear relationship. So at the 0, then the character is sort of turning at a sort of like a slow speed, and then when you get to the full extent, like left, it's like full spin to the left, right? So what you want to do is keep the speed at the extremes the same, but it doesn't give. If you can rotate quickly, it's going to be not very sensitive in the middle. So how many games implement this? I'd like to see more games implement this. Implement what? How beautiful is that? This is beautiful. I'm sorry. I'm going to blow my own trumpet and say this is beautiful. For the life of me, well, I won't go there. What I wish is I'd had Desmos when I started teaching, because I could. It's so useful for showing this kind of stuff. You see, at the moment now, I've got incredible level of precision in the middle. So you could aim. You can use this in a first-person shooter. You've got really extreme precision in the middle. Right, look at that. A lot of the movement of the stick just concerned with that. In fact, maybe I can show the actual position of the stick. Why not? The position of the stick. Where are we? How do we do position of the stick? where the hell is that in this sheet? I need to just find it. Well, it's J. It's the joystick, right? It's going for it. So what I will do is add another. It's a black. Okay, I can add another one of these that shows you the position of the stick for comparison. Yeah. Why doesn't that work? It's because... Oh, I didn't do it right. Yes, it's x minus j. Yes. Yeah, that's nice, actually. Can you see how it's going? The red one is the position of your stick. And the black one is actually where the stick is read in your code. And you can have it linear. You can have it so that there's greater precision in the middle. Two extremes. It's a very simple formula, actually, relatively. It's this formula here. It's one formula does the whole thing. That's my normalized tunable sigmoid function. And I know for a fact, this for me is how difficult this can be to sell. I mean, I know, I learnt the hard way on that one. So this for me is what you want for sensitivity, not any of this silly, just change the, rate at which you turn thing. Do this. Thank God, look at that. Look, still full range of motion. And of course you can go the other way. This is the other thing, which makes it counterintuitive. But if I go like this, you've actually got less precision. It's sort of anti-precision. But that, when you do this, you've got more control, fine control over high velocities than you have over low velocities. And depending on your game, you might want to be able to do that. Yeah. And now I've had a bunch of people get in touch with me, a few people get in touch with me that have seen this formula and they're using it. I think there's at least 3 developers. So the response from the GDC thing that they fill in, I was a bit disappointed with how it got, the score I got. But I know that this is useful, and it's and that's why I don't like those scores. In fact, I never look at them. I will never look at them again if I ever do talks at GDC. I'm never going to look at my score because it's what the hell. It's not really constructive feedback a lot of the time. It kind of put me off a little bit. One of the ways you can call this is as a smooth step function, because you can see how if I do this, it's a step function. It goes -1 in, gives you -1 out, 1 gives you 1, and then it switches at 0. At the ultimate extreme of this, you get a step. So you can then go anywhere between a step function and linear. And so I use this for if you're looking yesterday and you saw me looking at the interpolation of tactics, it uses this function so that you can either step the position from one zone or to another zone of the player. That's how it was in kickoff, right? As the ball crossed a certain boundary, the position of the where the player stood, would switch. So in KOR, I have interpolation. But you could do this kind of interpolation. But that means that then people are not, I mean, the players are not sort of focused at all on their tactical position, which doesn't feel right. So you could use this, use this. So it sort of wants to gravitate to its tactical position, and it will switch between them, but instead of popping, it's actually a continuous thing between us. Good, isn't it? I use this everywhere. Anyway, that's enough of that. I'll go back to what I was trying to work on, which was the dead zone processing. Check dead zone processing. Check dead zone. Right, it's a tunable. It's a tunable parameter. Dead zone in tunables. Let's have a look. Input. Dead zone. Yeah, that's 0.25. I mean, you see what happens if I try 0.3.